Okay, now we're going to reflect the pre-image. Remember, the pre-image is what we started off with across the y-axis, and record the new prime points also. So put our patty paper back, and we're going to flip it across the y-axis. Okay, so now where's A prime? Where's A prime? Huh? Negative 1, 2. And where's B prime? Negative 4, 5. And where's C prime? Negative 5, 3. Now, when we reflect, now they want to ask this question. So what happened to the x coordinates when we reflected across the x-axis? They stayed the same. What about what happened to the x coordinates when we reflected over the y-axis? So we're going to say the signs changed. Because it's a rule, but if it was originally negative, it would have turned positive. So we'll say signs changed. All right, so then we reflect across the x-axis. What happens to the y-coordinates? Signs changed. And now reflected over the y-axis. What happens to the y-coordinates? Stayed the same. So when it asks for a rule, it means a symbolic rule. So instead of me just saying, oh, they stayed the same and changed, I would write it like this. I would say, okay, I'm starting with my original point. And this is for the x-axis. Starting my original point, and then when I transform it across the x-axis, my x sign stays the same and my y sign changes. Okay, so even though I'm putting a negative, if it was already negative, it would change to positive. Okay. And then for the y-axis, I start off with my original pre-image point, and my x sign changes, but my y stays the same. All right, let's look at reflections 2. We're gonna start off with the same pre-image first. So plot that. 1, 2 is A. 4, 5, B. 5, 3, C. And put it in your table. 1, 2, 4, 5, and 5, 3. Okay, this time they want us to place the patty paper over the graph again and trace it. We already did that. So all we're doing now is we're graphing the line y equals x. So that's why we did that in the warm-up. We're going to graph the line y equals x. So that's what the line y equals x looks like. And we're going to flip over that line. So this time we're going to flip diagonally. So now where is A prime? Where is A prime? A prime is 2, 1. So if you see, it's half away from y equals x, half away in the other direction. So 2, 1. Where is B prime? It's not at 4, 5. That means it wouldn't have moved. Huh? 5, 4.
Yeah, that's how they stop
What about C prime? Okay. So in that case, since the original pre-image was on top of y equals x, the other one is still going to be on top of y equals x. It just flipped over. Okay. Now we're going to reflect over the line y equals negative x. We're going to go straight through 0, 0, but going downward. Okay, so again, we're going to flip, but now we're flipping over y equals negative x. So it was originally over here. So I'm going to take the corner and flip that corner to this side. So where is my new A prime? A prime would be at -2, -1. What about B prime? -5, -4. What about C prime? -3, -5. Okay, what happened to the x and y coordinates when we reflected over y equals x? So what happened from this pre-image to this image? What happened? The x and y switch places. What happened from the pre-image to reflecting over y equals negative x? From the pre-image to y equals negative x. So they switch places, the x and y switch. And signs change. So when it says reflect, do your rule, you're going to do it symbolically. So originally I started off with x, y. So when I reflect over y equals x, how would I change? How can I show that symbolically? From x, y to what? Y, x. Because they switch places. And then when I reflect over y equals negative x, I start off with x, y. And that will go to what? Negative y, negative x. Very good. Okay, now we're going to flip to translations. We're going to start off with the same pre-image. Same pre-image, though. Still 1, 2, 4, 5, 5, 3. 1, 2, 4, 5, 5, 3. Okay, so on this one, it's a translation. What's the simple word for translating? Slide. Okay. So you can actually slide the patty paper, but I think it's really, with translation, you don't really need the patty paper to demonstrate. Okay, it says we're going to move horizontally 5 units to the left. So where would my new A prime be? Five units to the left. -4, 2. Where would my new B prime be? You said -6? Not -6. -1, 5. -1, 5. Okay, and then where's C prime? 0, 3. Okay, this one I wanted you to do again. So that means you're not going to go to the pre-image. You're going to go from the last image you did. So now we're going to go vertically 3 units down. So where's that A double prime going to be? So I'm going to go 3 units down from my image. -4, -1. Then what would B double prime be? -1, 2. And what about C double prime? 0, 0. Okay. So this time we did 2 translations. We did one and then we did the other one. So what happened to the x coordinates when we moved horizontally? What happened to the x coordinates when we moved horizontally? How? But how?
They changed signs.
I mean, the number would be the same. What you say, Maria? They subtracted 5, so they went down 5. And so then what happened to the x coordinates when we moved vertically?
Changed signs.
So looking at the pre-image to the vertical, did anything happen on your x? I mean, no, from your image to your new image, huh? They stayed the same. So when you move vertically, nothing happened to it. What happened to your y coordinates when we moved horizontally? Stayed the same. What happened to your y coordinates when we moved vertically 3 down? Down 3. I subtracted 3. Okay. So the way you would write that is you start off with your original point, x, y. And then for x, we subtracted 5, right? And for y, we also subtracted 3. My bad. So you would write it like that. Okay. This is called mapping notation. Okay, what is rotation? What is the simple word for rotation? To turn. Okay. In this demonstration here, we're going to rotate counterclockwise. Which direction is counterclockwise? To the left or to the right? Left. Okay. What quadrant is this one? What about this one? What about this one? 4. I want to mess with you. What about this one? This would be 3. Okay. Okay, we're going to start with our original point at 1, 2, 4, 5, 5, 3. Okay, so our 0 rotation and our pre-image will be the same points. 1, 2, 4, 5, 5, 3. Okay, so if I rotate 90 degrees counterclockwise, how many rotations is that? That's 1 turn. Okay. So I'll put my patty paper back on there. And I'm going to do 1 turn. Counterclockwise, so to the left. So where is my A prime now? Negative 2, 1. Where's my B prime? Negative 5, 4. What about C prime? Negative 3, 5. Okay, then now on these they do have rules. I just don't use the rules because it's too many of them to memorize. So with me, I actually either gonna use patty paper or I rotate my whole paper. Okay, so rotate 180 degrees. How many turns is that? 2. And where's my new A prime? Negative 1, negative 2. B prime, negative 4, negative 5. C prime, negative 5, negative 3. Okay, what about 270? How many turns is that? 3. So where would 270 A prime be? 2, negative 1. B prime, 5, negative 4. And C prime, 3, negative 5. And then of course 360 would be back to what? The original pre-image. That's when people say they made a whole 360. They sound dumb, because that means you started back at your beginning. You didn't change it all. Okay, so let's answer the question. It says, what patterns do you notice about the ordered pairs? I already gave you the patterns under here. So if you want to have the rules memorized, you can memorize those rules. If you need me to show you how I rotate the paper so I don't have to memorize rules, I'll show you that later. When you rotate 90 degrees, what quadrant was the image in? 2. And how many quadrants did I move from the original image? 1. When I rotated 180 degrees, what quadrant was I in? 3. And how many quadrants did I move from the first one? When I moved 270, which quadrant was I in? And how many quadrants did I move from the first one? And when I rotated 360, which quadrant was I in? And how many quadrants did I move? Technically 4. Okay. So the person tried to change, they just ain't changed all the way. They went back to their original ways. Okay, dilations. We're going to plot point C, which is at negative 6, negative 5. Okay, then we are going to plot triangle DEF. So negative 3, 1, 6, 4, 3, negative 2, okay, originally I did say dilate the triangle about the origin, but we're going to change that. We're going to dilate about point C. Okay, we're going to dilate about point C. And the scale factor is 0.5, which is the same thing as 1/2. All right, to dilate about a point, first, find the distance. Well, find the slope. I'm going to say find the rise over run. from the center of dilation to each vertex of each vertex. And then multiply the rise over run times the scale factor. Find the rise over run from the center of dilation to each vertex, and then multiply the rise over run times the scale factor. Okay, so pay attention to what I'm saying. All right, to go from C to D, I had to go up 1, 2, 3, 4, 5, 6, and then over 1, 2, 3. So I went up 6 over 3. Now, my scale factor is 0.5, so I multiply my rise over run times 0.5. So what's half of 6? 3, and what's half of 3? 1.5. So instead of going up 6 and 3, I'm going to go up 3, 1, 2, 3, and over 1.5. And that'll be my new point for D prime. And then I'll go to C to F. So from C to F, I had to go up 1, 2, 3. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's half of 3? 1.5, and what's half of 9? 4.5. So now I'm going to do half of that. So I'm going to do that. So now I'm going to go up 1.5 and then go over 4.5. F prime. And then my last one, I got to go from C all the way to E. So I have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I went up 9 and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So half of 9 is 4.5, and half of 12 is 6. So up 1, 2, 3, 4.5, and then over 1, 2, 3, 4, 5, 6. So it's the simple thing of counting. Okay, it's the simple thing of counting. So I'm gonna go ahead and connect those. Now, a way that you could tell if you did it right is that your lines from each vertex to the center of dilation should be linear. Okay, so I'm gonna show you what I mean. So if you're unable to draw a line from your pre-image to your image to your center of dilation on each vertex, that means you did something wrong. Okay. Okay, let's talk about this other part, and then we're gonna be done. Okay, it says, what is the dilation? So for it to be a dilation, it has to get bigger or smaller. So you're going to do an enlargement or reduction. When you do your definitions on the front, you're going to find out what the word isometry means, and you're going to figure out if dilations represent isometry. Okay. You're going to fill out the rest of this as part of your homework.